So today we are going to start the topic of permutation. First of all, you need to remember the permutation formula, which is NPR, n factorial over n minus r factorial. So let's solve one question. If we need to find 20p3, n is 23 is considered as r, so use the formula 20 factorial over 20 minus 3 factorial. And solving this 20 factorial and it is 17 factorial. We expand this 20 factorial with 20, 19, 18 and 17 factorial, which will be cancelled with the denominator, and you're left with 6840. Here is the question number 2. So first I will try the second part, and the other parts are same. We have 11pn is equal to 11, 10, 9. What you do, we have to make the factorial form in the right hand side. So for this, we'll multiply by 8 factorial over 8 factorial to complete this factorial. So numerator become 11 factorial over 8 factorial. If you look at this, the both side comparing, numerator is same, so it means the denominator should also be equal. So we write them equal. If their factorial form is equal, it means the number also equal. So 11 minus n would be equals to 8 and 11 minus 8 equal n, which give you n is equal to 3. So on the third part, this is the ratio. Ratio means they are dividing. So np4 over n minus 1 p3 equal 9 over 1. Now we need to open up. So on the numerator you have np4, which is open as n factorial over n minus 4 factorial. So I will write the divide sign like this so that I can change it later on. So n minus 1 factorial over n minus 1 minus 3 factorial. Now division will be changed into the multiplication, so the fraction will be flip over, and n minus 3 minus 1, which is considered as n minus 4, which goes on the numerator, and n minus 1 on the denominator. Same terms will be cancelled out, and you left is n factorial over n minus 1 factorial equals 9 over 1. And when we expand this n times n minus 1 factorial, so n minus 1 factorial will be cancelled out, and we're left with n is equal to 9 over 1, which is 9. In question number 3, we have to prove the first principle, and these two are the different questions. So I would solve one of them and you will be able to solve the next one. So second would take as NPR equal n minus 1 PR plus R n minus 1 PR minus 1. So I would take the right hand side, n minus 1 PR plus R times n minus 1 PR minus 1, using the same formula. So numerator, the factorial of the n minus 1 over n minus 1 minus R plus R times numerator n minus 1 factorial and n minus 1 minus r plus 1. Why plus 1? Because minus of this r term, which will be minus and minus become plus, that's why it will come plus. Now if we notice in the both term we have n minus 1 the same, so we take it as common, and the first is left over 1 over n minus r. I'm just rearranging this, n minus r minus 1 factorial plus r over n minus r factorial. And now we open the denominator term, 1 over n minus r minus 1 factorial as it is, plus r over n minus r minus 1 factorial. Now again the same term will be taken as common. We left 1 plus r over n minus r. Taking the LCM over n minus r, these terms will be cancelled out, and you left with n times n minus 1 factorial over n minus r and n minus r minus 1. This was n minus 1 factorial. So it's complete as n minus r and it's complete as n factorial, which is npr, that is your left hand side. In question number 6, they are saying how many words can be formed from the letter of the following using all letters when no letter is to be repeated. So it means we have to arrange all of them and there will be multiple ways to arrange. So we have the 5 numbers and we have arranged all of the 5. N is 5 and R is 5. We do 5P5 which is 120. And same for object, the total number of letters are 6 and we have to arrange all of them. It will be 6P6 which is 720. Question number 5, in how many signals can be given by 6 flags of a different color when any number of flags can be used at a time. The total number of flags are 6. So any of the number can be used. We can arrange first taking 1, then 2, then 3, then 4, then 5. There are different flags we can take and we can take any of the one at one time. So first we do 6 and we arrange 1. So 6P1, then 6P2, 6P3, we can find 6P4, 6P5, and by using the calculator you can find these values, which is 6, 30, 120, 360, 720, and 6 permutation 6. This is also 720. How to find by using directly from the calculator? So it's very easy. Let's close this up. So what do? Well, let's suppose we need to find 6P2. So you need to first press 6, then the permutation NPR. But the NPR is not a direct button, so we will press with the shift. So when you press shift and this X, it will be considered as NPR, and then the second number R we will press, that is 2. When you press this, you will get the answer 30. In this way, you can find directly from the calculator. Now the question is, find the number greater than 23,000 that can be formed from the digits 1, 2, 3, 5, 6 without repeating any digits. This number is 23,000 and we need to make the number bigger than this. So to make the number greater than this, if you notice that this first two digits is 23, it means if we want to change the first digits, it can be more than 2 or 3. But first we have the other number 1, 5, 6. Here are zeros. So we can place any of the number in these 3 places, which will become automatically bigger than this because these are zeros. So first way is we remains 23 as it is, and in other 3 places we can replace any of these numbers. So the permutation will be, we choose from 3 digits, we arrange 3 digits. So we need to find 3P3. If you solve this by using the calculator, it would be 6. So you would say the number of the form 23 with the next 3 digits can be arranged anyway, so it will be 3P3, which is 6. And same next number bigger than this will be, we fix 2, but we can change now 3, but it must be bigger than 3 from these digits, so it would be 5. So now we fix 2, 5, and the other 3 number can be arranged in these 3 places. So it means the 3 from 3 digits we can replace 3 digits. So it remains as 6. Now we are again going to fix 2, but the next digit can be as 3 and other 3 numbers can be arranged any way, and that will becomes the number of ways. So it will become again 3P3, which is again 6. So 6 digits by using this way, 6 digits by using this way, and 6 digits by using this way. These numbers will become by using these ways. Now in the place of 2, we can write 3, and other 4 numbers can be arranged any way. How many ways? By using 4P4. There are 24 ways to arrange the remaining 4 digits. So the next number will be more than this, will be, of course, the 5 will be in the start, and next 4 digits can be arranged any of the way. You can write first, you can write 1, then you can write with 2 here, then you can write with 3, and each number will be in each place, and total number of ways would be 4p4, that's again 24. Same the number of the form with start with the 6 and remaining 4 digits can be arranged any way on these one by one. So total number of ways will be 4p4, that's again 24. So the total numbers by using this ways, we will have 6 plus 6 plus 6 plus 24 plus 24 plus 24, and there are 90 numbers can be made which are greater than 23,000. In this question, they said how many 6-digit numbers, we need to make 6-digit number, can be formed without repeating any digit from these 0, 1, 2, 3, 4, and 5. In how many of them will 0 be at the 10 places? So since the total numbers are 6, so n would be 6. Now we need to focus on this, the 0 number, because if you make any number, for example, you make 0, 1. 0, 1 means 1. 0, 5, 2, 5. 0 to 5 means it's just 25. So it means if you have the 0 at the left side, it is nothing. It is considered as nothing. So we need to focus on that the 0, when the 0 is on the extreme left side, so the remaining would be the 5 that we need to arrange. So when 0 is extreme left side, then we have the remaining 5 digits which we need to arrange. So the permutation would be 5. We need to arrange 5. It would be 120. But if we don't write the 0 on the extreme left side, so for the number which will be formed by the 6 digits, so these are the numbers when we use all 6 digits, and these are the number when we use only 5 digits. But the 0 is still at the first place. But the 0, if the 0 is still at the first place, whatever the other 5 digits, it is still a 5-digit number. But we need to make the 6-digit number. So we'll subtract all of these 5 digits from this, because in this the 0 will be at the first place. So the total 6-digit numbers would be 720 minus 120. Why we are subtracting 120? Because in this the 0 is first place. So if the 0 is at first place, the number will be a 5-digit number. We don't need a 5-digit number, we need a 6-digit number. So we subtract all of those numbers which will be formed by placing the 0 at the first place, which is 600. These are the numbers which are formed using these 6 numbers. Now the point is, they said in how many of them will be 0 at the 10th place. So this is a separate question. So we need to give the answer. If we fix the 0 at the 10th place, then obviously we have the remaining 5 to arrange. So when 0 fix at 10th place, so then it would be 5p5, which is of course 120. So these are the numbers which are formed by fixing the 0 at the 10th place. Now we need to make the 5-digit number, which are the multiples of 5, and it can be formed by using these numbers when no digit is repeating. So as you know that when we are making a number which is the multiple of 5, so any number the multiple of 5 have the last digit should be 5 or 0. But in this the 0 is not included, so last digit should be 5. So this is the fix. When one number is fixed, so we have to arrange the other numbers. We don't need to, because we are making the multiples of 5. Just like multiple of 5 is 5, 25, 35, 45. Another also has 10, 20, 30, 40, but we can't take these because we don't have the zero to write at the end place. So we only focus on the number which have the end digit with 5. So 5 is fixed, remaining are 4. So we will make the 4p4, which makes 24. So other numbers can be arranged anyway, but the condition is the last digit must be 5. Now this question they are saying how many ways can 8 books include 2 books on English can be arranged on a shelf in such a way that the English book are never together. So the condition is again here that English books are never together and the 2 books of English can be arranged. We have to arrange the 2 books and the total are 8 books. So whatever the condition, so we have the 8 books 1, 2, 3, 4, 5, 6, 7, 8. So they said the English books can never be together. So first of all, if we will check that how many ways to arrange these 8 books without thinking about the English books. Number of permutation for 8 books, it would be 8p8, which is equals to 40,320. So this is the total permutation for the 8 books. Now let's think about that when the English books comes together. So let's suppose the English books comes together. There are two ways that English book comes together, like first E1 or the second book, or another way is second book or first book, because this is a permutation and in the permutation the order matters. Like if you change the order, that's a different thing will be happen. So E1 E2 arrange this way or E2 E1 arrange this way, both are the different things, so they are considered the both separate ways. So let's find how many permutation of this and how many permutation of this. After that, we will subtract these two permutation from the total permutation. That give us the remaining number of ways in which the English books will never be together. So the permutation of E1 and E2 in which this one set is fixed and the remaining will be the 7. So it would be 7p7. And same here, this one set is fixed and remaining is 7p7. So when E1, E2 together, it will be 7p7, which is equals to 5040. And when E2, E1 together, which is again 7p7, which is 5040. So including the both, they are equals to 5040 plus 5040, that is equals to 10,080. So this is the total number of ways when these English books together, but we need to find when English books will never be together, so we subtract this from the whole. So number of permutation when English books never together, this would be equals to 40,320 minus 10,080. So if you subtract these, we will have 30,240. This is the remaining number of ways when the English books never together. So here is the question. They said find the number of the arrangement of 3 books on English and 5 books on Urdu. So let's we call the 3 books of English as E1, E2 and E3, and the 5 books of English Urdu as U1, U2, U3, U4 and U5, for the placing them on shelves such that the books on the same subjects are together. So they all should be together, they all should be together. So we have only two options, that first we have English books and then we have Urdu books, or we have the first Urdu books and then we have English books. So we have these two ways and they will be together. So if they will be together, then we have to arrange them and we will multiply their permutations. So when we have the books are arranged, so when books arranged, first all English and then all Urdu. So how many permutations of this? There are three and we have to arrange three, of course. So it will be 3p3 and times, these are 5, so 5p5, and the total is, the permutation of this is 6 times 120, which is 720. And when books are arranged by this way, like first you have Urdu books and then you have English books. So this is 5p5 times 3p3, which is again 120 times 6. That's total number of ways is 720. So the total permutation for arranging all, that is equals to 720 plus 720, which is equals to 1440. Now here's the question, that in how many ways can 5 boys and 4 girls can be seated on the bench that the girls and boys occupied alternate seats? There are 5 girls and 4 boys. We have to arrange them in alternate ways. If you have the boy, then girl, then boy, then girl. So if we call it B1, B2, G1, G2, B3, G3, B4, G4, and B5. Yes, these are 5 boys. 5 boys and 4 girls. So we should start with boys so that it can be end up with boy. So now we have to write the permutation of all these. So if we are making the permutation of this, so we have to multiply the permutation of all. But how? So to make the permutation, when we are making the permutation of the first boy, so there are total 5 boys. So from the 5 we are choosing only one. Now here the girls are total 4. So from the 4 girls we are choosing one. And when it's time to choose from the next, so we have already choose the first one, so the remaining boys are 4. Now from the 4 you need to choose one, and same, there are remaining 3 girls left behind, so from 3 we have to choose one. Same, when we are choosing the third boy, so we already have the choose first 2, so the remaining 3 will be choose from the 3. So from 3 boys we have to choose one, and here we have already choose 2 girls before, so the third girl will be choose by from the remaining 2, so 2b1. And same, now when we are choosing from the fourth boy, so we already choose the third before, so remaining 2, from 2 we need to choose one, and here from the last girl we need to choose one, and here we from the last boy we need to choose one. So we will find all of this and multiply all of them together. So let's find it. It will be 5 permutation 1 times 4 permutation 1 times 4 permutation 1 times 3 permutation 1 times 3 permutation 1 times 2 permutation 1 times 2 permutation 1 and times 1 permutation 1 times 1 permutation 1. We need to multiply all of them together, and when we multiply them it will be, this one is 5 times 4, 4 times 3 times 3 times 2 times 2 times 1 and times 1. So we will multiply all of them. It will give you the total 2880 ways to arrange the girls and boys when you have 5 boys and 4 girls and you need to arrange in alternate ways. This is the whole idea about the permutation.